Space stations. If you want to go up into space to see some stuff, you need to be able to survive up there. Basically what that means, if you think back to the biodiversity unit, there's like Earth is kind of our niche, and we can find ways to survive within that. Space is definitely not our niche. So we need to make space as close to Earth as we possibly can. That's what space stations are for, is for people to live up there where we've created an Earth-like environment. I know this picture doesn't really look like Earth, but the things that you can't see are the fact that there is air pressure in here. There is food and water that humans can actually digest in there. So that's kind of how we do that. We've got, you probably heard of Hubble Space Telescope and Canadarm. These are basically part of our program so that we can look at different things, we can see different things. The Canadarm, kind of like, I don't know, it's almost like a repair piece. And then Hubble Space Telescope is like this super powerful telescope in space so that we can get clearer pictures of further out planets that aren't affected by the Earth's atmosphere. Because if you're on the Earth and you look up at something, it's all going to be distorted because of this layer right here all the way around the Earth. We've got an atmosphere, which is gas, and so when light from other planets is coming in through this layer, it gets distorted, and then it gets to you with your telescope right here. So you're not getting a true picture. But if we have something like the Hubble Space Telescope out in space, where it's beyond the atmosphere, now we're looking at this same beam of light from right here before it has a chance to get distorted. Canadarm can help retrieve stuff, it can fix stuff. It's a pretty multifunctional tool. So if we're going to go up into space, I said we need to create an Earth-like environment. That is so that we can actually survive. Because let's think about one thing first, your lungs. In this picture down here, we can see this first one, this is how you look normally. But your lungs are filled with air. Air is a gas. If you put gas in a really high pressure area, it condenses, so it gets smaller. If you put it in a really low pressure area, or no pressure, it expands. And it can expand so much so that it could cause your whole chest cavity, your thoracic cavity, it could make your rib cage physically crack and explode if it expanded too much. So that's kind of what we're showing right there. That's why inside of your space station, you would have to have air pressure. Same thing with like even airplanes. The cabin of an airplane is pressurized. That's why you can't open the window on an airplane, because all of the pressure would go out, and then you would get this happening to everyone on the airplane. Same thing with like scuba diving. There's a rule with scuba diving where you don't hold your breath, and that's because when you hold your breath, you're basically filling your lungs up with air, and then when you go to a different depth of water, it can expand or contract, one of the two. If you're not holding your breath, it doesn't happen to the same extent. So then you get, let's say you're adjusted up in space and so you're back to normal. When you come back to Earth, well, your lungs are now used to a smaller amount of pressure. So they would contract on themselves because there's now more pressure, and now you've got the opposite problem happening. This is where you can end up with a collapsed lung, and those are no fun. So those are some of your environmental hazards. So environmental hazards, you need to create an Earth-like atmosphere. Kind of the same thing with your physiological effects. You need to be aware of how your body is going to respond to different levels of pressure. As far as psychological challenges go, humans were not, like our brains did not develop to be in the middle of space where there's literally just nothing. Our brains have been programmed to be like, if I see nothing, that means there is something wrong with me and a lion is coming to eat me. So when we're out and there's just nothing, it kind of messes with your brain a little bit. So that's why, like, you will never have a solo space mission. It's never just one person. There's always going to be a team, and then you can kind of help each other out that way. Yeah. Okay, no air or water in space. So what you do is you bring your own. And the problem is, like, if you think humans need 2 liters of water every day, and let's say you have a team of 6 people, that's 12 liters of water every day, which means 12 kilograms of water. If you want to be up there for like a month, 30 times 12, we're looking at a significant amount of weight that we really don't want to bring if we don't have to. And then if your space mission goes on for longer, we don't want to be carting all of this water around if we can find a better way. So what they do is basically reuse water for all purposes that they need it for. Like they can recycle almost all of it. Remember the orange thing with the glass bulb at the top that we had set up where the hydrogen gas and the oxygen gas came out of the water? That's what they do in space to make their own oxygen to breathe. So they take water and they split it up into hydrogen and oxygen. They send the hydrogen outside of the spaceship and they keep the oxygen and then they breathe it. In terms of sunburn, like we can just wear sunscreen on Earth and we're totally fine. That is again because of this small layer of gas right there. Our atmosphere shields us from the UV radiation from the sun. If you are in space, so if you go to right here, you don't have that anymore. And your body has not been built to withstand that level of solar radiation. So that's one of the things that they have to take into account with these spacesuits. Yeah, temperature is the other big one. Talking about space junk. So I said earlier that we're trying to be more sustainable, more mindful of what the future of our space exploration is going to look like. Not so when humans first started launching stuff up into space. We kind of just put our stuff wherever we felt like it because we're like, there's so much room out here. It's not polluted at all. Let's start polluting it. And now the problem that we have is that all of that stuff is still there. It hasn't gone anywhere. And so if you have the tiniest little thing, like half a gram, think like a sugar cube-ish, that can do so much damage in space because it's going incredibly fast. So if we think that speed is just kinetic energy, when that hits something, that energy makes this hole, or this, it's more like a crater right there. So that is your space junk. In terms of the satellites that we put up there, these are useful for us for things like GPS, for trying to predict the water, for like satellite phones. If you go out into the backcountry and you lose cell service, you can communicate via satellite. That brings us to the end of this chunk. So you have some time now. I said brochure there, that should say study guide.